Welcome to Homework Lib.
Hi, so for this question what we're going to have is 150 milliliters of a zero point 0.1 molar solution of HCN. We are asked what is the hydronium ion concentration if in a solution prepared with this plus 1 plus 150 milliliters of a solution of NaCN, but you are not providing any concentration. Let's assume that this concentration of NaCN of this solution, assuming that this is going to be the same one, right? So the Ka for this acid, it is going to be 6.2 times 10 to the minus 10. Here I'm using a value from the page of the University of Washington of a table of acid and base strength. But if you have a source or book that you're using in your course, you should find the value there and employ that as the Ka for HCN. So now, we have two different scenarios. First of all, let's assume that the concentrations are indeed equal and that the problem is complete as is. We have, as you can see, an acid and its conjugate base present in solution because sodium cyanide is going to produce Cn minus ions in a quantitative way because this is salt. It dissolves and dissociates completely. So we can use the Henderson-Hasselbalch equation to find the pH. And pH is going to be equal to the pKa plus the logarithm of concentration of Ca minus that we're going to get divided by concentration of HCN that we have in solution. Here, what is going to happen is that each of these solutions are going to provide a certain amount of mole to the final mixture. But the final volume at the end, it is not going to matter at all, as I'm going to show you in a second. If we do concentration of Cn minus divided by concentration of HCN, remember that these are in molarity. This is nothing but amount of mole of Cn minus divided by the total volume divided by the amount of mole of HCN divided by the total volume. So the total volume, when we have a buffer, at the end it is not going to affect the pH. The thing that is going to affect is the amount of mole that we have of each of them. So the amount of mole of HCN that I'm going to have in solution, it's equal to the volume in liters times the molarity of my solution. This would be 0.150 liters because we have 150 milliliters times the molarity that is 0.1 molar. And in the case of amount of mole of Cn minus, same thing, it would be the volumes times the molarity. The volume is still 0.150 liters. And in this case, I am assuming that the concentration is the same. But if for some reason you missed that value in the problem or that concentration was provided in a previous question, you should replace this value, okay, with the correct concentration. Here I'm just assuming there it is. As you can see, the result it is going to be 0.0150 mole in both of them. So the amounts of mole are going to be the same. We can calculate the pKa as minus the logarithm of Ka. It is going to give us a pKa of 9.2. Thus, the pH is going to be equal to pKa plus logarithm of concentration of Cn minus divided by concentration of HCN. We showed that this is equal to pKa plus logarithm of amount of mole of Cn minus divided by amount of mole of HCN. And since both of these guys are equal, this would be 1, and logarithm of 1 is equal to 0. So the pH becomes equal to the pKa of the acid. And pH would be equal to 9.2. And that would be all. Here, the only thing that may change is that the amount of mole of Cn minus could be altered depending on the concentration of the solution. And that will be all. Thank you very much.